All right, good morning, guys. We are going to do our notes today from a video. I'm feeling sick, so I'm staying home today. But the big idea today is that we're still going to practice changing our equations from standard form into our vertex form. And then we're going to take it one step further and actually use that to help find our vertex and then find the x-intercepts, because those are all of the things that we're going to need in order to create a graph. And so that'll be tomorrow's goal. We'll do the same sorts of things tomorrow, except we will actually put the information that we found on a graph. So starting with question 1, remember the big idea when we're trying to put things into vertex form is that we're trying to rewrite this last term as two other numbers that are equivalent. So two other numbers that can add or subtract to 3. And the reason why we're doing this is because we want to create our perfect square with some extra, right? That adjustment to get us back to 3. That way, looking at our vertex form, we have our perfect square portion and our extra portion. So in order to figure out how to rewrite that 3, we're going to make our area model. And inside of our area model, we always put our x squared on the top left. That 4x is going to have to split into 2x and 2x. And the reason why we're splitting that in half is because we're actually trying to make an actual square where all of the sides are the same. And the only way to get these sides to be the same is if our boxes are the same. So thinking of what the sides would be, x squared is always x and x. So then we're thinking, well, x times what would make 2? And that would be 2. Same thing over here, and notice how we're getting the sides to be exactly the same. So what that tells us is that in order to complete our square, we would need 4 right here, because that's 2 times 2. So one of the numbers we would need to rewrite 3 with would be 4. And then we want to think about, well, what would we have to add or subtract to 4 to really make our ending value 3? And that value is -1, right? 4 minus 1 is 3. So let's put everything together, right? X squared plus 4x plus 4, that's everything in this box. And instead of thinking of the area as adding up all of our boxes like we have written, we could think of our area as length times width. So x plus 2 times x plus 2. And if we're multiplying by the same thing twice, we can rewrite that as squared. And that -1 will come down as our extra piece. So that's our equation right here in vertex form. The other things that it's wanting us to do today is to write our vertex and to write an equation to find our x-intercepts. So I actually want to scroll back up really quick to when we were finding our vertex. So hopefully we remember doing this activity where we typed all of these into Desmos and I asked you to write down what the vertex was. And one of the patterns that we noticed was that this number in our parentheses always goes with our x-coordinate of our vertex, except that it turns out to be opposite. So if we have a -2, the x-coordinate is +2, +4, -4, -3, +3. So that's how we get that x-coordinate. To get the y, that's the number that's written on the outside, and nothing changes to that sign. So since there's nothing written on A and B, we can assume that there's a +0 there. So that y coordinate is 0, right? This +2 turns into this 2, this -7 turns into this -7. So going back to the question that we are working on, if we want the vertex, right? The number inside with our x gives us our x coordinate, but turns out to be opposite. And the y coordinate is that number on the outside, which stays the same. Okay. So one thing that's a little bit new today is this last portion where we're trying to write an equation and solve it to find the x-intercepts. So if we're thinking about like what x-intercepts are when we graph, if I pick anything, any number, any point on my x-axis, the y-coordinate of that point will always be 0 because we haven't gone up or down any from our origin. So if our y-coordinate is always 0, we're going to take our equation and set it equal to 0. Change y to be 0. And now we want to solve for x. The really nice thing about having our vertex form instead of standard form is because this is actually something that we can do our like reverse PEMDAS or whatever you want to call it on, where we would add 1 to both sides, square root, all those sorts of steps. And the reason why we can do that is because we only have one kind of x. What made it hard for us, remember why we factored, is because we couldn't really do that when we had an x squared and an x. Even though those are both x's, they're kind of still like two different kinds of variables, which made it hard to get our x by itself. But for this, since we only have this one kind of x, we're able to do some reverse steps. So I always like to teach it with PEMDAS, right? That's our order of operations, but in reverse. So just basically the steps that we would do to solve an equation, right? To get x by itself. So hopefully we're seeing the very first thing we would want to do is add 1, right? 0 plus 1 is 1. X plus 2 squared is what we have left on the right. And there's nothing we can do with this plus 2 yet because it's stuck inside these parentheses. It's kind of being like protected by that square. So before we can touch that x plus 2, we're going to have to undo that square. To undo that, we square root. So our square and our square root is gone. When we square root 1, we actually get 2 answers. A square root means what number times itself will give us back 1. Well, 1 times 1 gives us 1. Negative 1 times negative 1 also gives us 1. So we'll always get 2 answers for that square root, a plus version and a minus version, which means we're going to get 2 equations for 2 x-intercepts. And then the very last step would just be to take those equations and get x by itself. So subtract 2. So x equals negative 1. Oops. Subtract 2 here. So x equals negative 3. And those would be our x-intercepts. So tomorrow, what we would end up doing is taking all this information that we just found and using that to help create a graph. All right, we're gonna try one more together and then you'll be responsible for trying that backside out. So question 2 is a little bit tricky because hopefully we're noticing that we have this negative up front, which we haven't really had before. All of the examples that we've done have just been x squared. So we actually want to take this equation and make it sort of look like this, where we only have an x squared. And the way we're going to do that is by taking out, we could kind of call it that greatest common factor, like we did with factoring. So since we don't want that negative there, we're going to take that out. That's going to be like our GCF, and we'll come back to that later. So if we take out that negative, that's the same thing as dividing everything by a negative 1. So we're left with x squared minus 4x minus 7. And now this is the portion that we're going to focus on completing that square with. And that negative will just hang out. We'll see where that comes in a little bit later. So again, big idea. We're trying to rewrite this last term so that we end up with a perfect square. Let me put a little line here so this doesn't get lost. Okay, so if we're thinking of our box, x squared, this negative 4x, we're going to split as negative 2 and negative 2. So to complete our square, we would need to add 4. And then we're thinking, well, 4 plus or minus what would give us negative 7? And that would be negative 11, right? So let's bring this negative up front down because it's not just going to disappear. It's always going to be there. And now we can rewrite this into perfect square form. So we have x minus 2. Oh, I made a mistake. Oh, no, I didn't. We're good. This was negative because we took out that. So x minus 2 squared minus 11. Right? That's going to be our perfect square form. The very last thing that we want to do is actually put this negative back in, right? Back into our equation. So we're going to distribute. It'll distribute to be outside of our first term. And it'll distribute to make positive 11 because negative times negative makes positive. So let's see, our final equation would be negative x minus 2 squared plus 11. All right, hopefully this is making sense. That negative up front, remember, tells us some things about our graph, right? It tells us that our graph is going to be opening upside down. So same sort of thing down here. That negative out front will tell us that our graph is opening upside down, right? That's what this tells us. For our vertex, right? Remember the x, the number inside with x always turns out to be opposite, so that's 2. The number on the outside stays the same. So our vertex is at 2, 11. And the very last thing we're trying to do is solve for our x-intercepts, right? Which means we're writing an equation where we're setting our equation equal to 0. And we're going to go through those same steps of trying to solve. So minus 11, minus 11. And before we can undo this square, we need to get rid of this negative, because right now, if I were to square root, we would have some problems, right? If you put square root of negative 11 into your calculator, it's going to give you a domain error because we can't take the square roots of negative numbers. But if we notice, we have negatives on both sides, so we can actually divide by that negative 1, which means now these are positive and this is positive. So 11 equals x minus 2 squared. Now we can take that square root. And remember, we're always going to get 2 answers anytime we square root something. We'll get a positive square root of 11, which turns out to be like 3.31. And we're left with x minus 2 on the right. We'll also get a negative 3.31. And we're left with that x minus 2 on the right. All right, last step is to solve our equation. So add 2 and we get 5.31. If we add 2 here, we'll get negative 1.31. And those would be our x-intercepts. All right, so you guys are gonna try some stuff on the back. I'm gonna put up some answers with all of our information right here that you can use to check. But the last thing that you're responsible for today once you get these done is just going to be to work on CYU. I think we're up to 14 today. Yep, CYU 14. So let me put up these answers and then you are just working. So on question 4, you're going to end up not getting any x-intercepts. You're going to end up kind of at this point in our equation, just like we talked about, having to take a square root of a negative number. And when we do that, we would just say stop, and there's no x-intercepts. On the graph, it would kind of look like this, right? Where our parabola is just going to be above the x-axis, and we're never going to cross through. On question 5, same sort of thing as number 2, where we don't want to see a 2x squared. We really just want to see an x squared. So we would factor out that 2 first, and then do that completing the square process with what's left over here. So our final answer there is 2 times x plus 1 squared minus 10. And so our vertex is at negative 1, negative 10. That 2 up front doesn't change the vertex. Remember, it just kind of changes how wide or skinny our parabola is. And last but not least, our x-intercepts would be negative 3.23 and 1.23. So hopefully this helps. The new thing today really is just finding those x-intercepts, but we're just solving an equation where we're setting our y equal to 0. So make sure you write down any questions that you might have so we can go over those tomorrow. But finish up CYU 14 and I will see you tomorrow. Bye guys.